Okay class, today video is about solving differential equation of first order and first degree. Now, there are four standard methods for solving differential equation, and the first one is the variable separable method, and the second one is the homogeneous equation, the third one is the linear equation of the first order, and the fourth one is the exact differential equation. So these are the four standard methods which can be used for solving the differential equation. Now let's try to learn these four methods one after another. So let's focus on the variable separable method. So what is a variable separable method? Now, if we have a differential equation, and if we can write the differential equation in this way, where you have the function of y, d of y, and the function of x, d of x. So if we can separate the different variables, like the variable of y on the left hand side and the variable of x on the right hand side. So if we can completely separate the variables, then we can use the variable separable method for solving those kind of differential equation. Now, for solving variable separable method, there are three steps involved. So this is the first step. The first step is to separate the variable. So which is already been separated. You can see that all the y terms is on the left hand side and all the x term is on the right hand side. So which means your variable is already separated. Now the second step, after separating the variables, we need to integrate both sides. We need to integrate both sides. And the third step, when both sides are being integrated, we need to add a constant. We need to add an arbitrary constant C on the right hand side. So this is the simple three steps which has been involved in the variable separable method. First, we need to separate the variable. Second, we need to integrate. Third, we will put a constant C on the right hand side. So now let's try to solve one problem, which is one differential equation where we can solve by using the variable separable method. Now, let's take this example. dy by dx is equal to x 2 log of x plus 1, and here we have sine y plus y cos of y. Solution. Now, in order to apply the variable separable method, we first need to separate the variable. So in this case, I can write this one as sine y plus y cos of y d of y is equal to x 2 log of x plus 1 and d of x. Now, if we check carefully, all the y terms is on the left hand side and all the x term is on the right hand side. So the first step is already been done. We have already separated the variables. So this is how the variable is being separated. We can clearly see that now. This is the first step. Now the second step is we need to integrate both sides. So let's try to integrate both sides. Sine y plus y cos y d of y is equal to x 2 log of x plus 1 d of x. Or we can write this one as sine y d of y plus y cos y d of y is equal to, here you will have 2x log of x d of x plus x d of x. So now we are having four integral, 1, 2, 3, and 4. Now how do we integrate these things? I believe we already know sine y d of y, the integral will be minus cos y plus, you just keep it as it is, y cos y d of y, and this one you just keep it as it is. You can take it out 2 outside, log of x d of x plus, if you integrate x, it will be x squared by 2. Now, 2 integration is been left, but if we see carefully in this integration, there are two functions. This is an algebraic function, this is a cosine function, and this is an algebraic function, and this is a logarithmic function. Now, if you are having more than one function in an integration, then we use integration by part. Then we apply integration by part. And you already know the formula for integration by part. Integration by part is given by, if you are having two functions, u and v, and d of x, then in that case you will have u v d of x minus integral of du by t of x integral of v d of x and dx. So this is the formula how to solve integration by part. Now, since I believe that you all know how to do integration by part, then in that case, this one is minus cos y plus, if we apply integration by part, this integral will give you y sine y plus cos y, when it is equal to, and this integral will give you 2 x squared to log of x minus x squared 4, and plus you have this x squared by 2. Now if we further simplify, then this two terms we can cancel out, so we are left with y sine of y is equal to, if we just give on multiplying, it's 2 log of x minus x squared 2 plus x squared by 2. Now these two terms can cancel out, so you are left with y sine of y is equal to x squared log of x. Yeah, and the third step. What is the third step? The third step is to add an arbitrary constant C on the right hand side. Now after integration is been done, we need to add the constant on the right hand side. So it will be y sine of y is equal to x squared log of x plus c. So where c is the constant. So this is the required solution of the given differential equation. And this is how we apply the variable separable method for solving the differential equation.